Ever wondered or came across these bots within GitHub repositories? For example, if you're looking around in the Kubernetes repository or Terraform, take for example, you'd see that for a bunch of the issues that currently exist in these repositories and even pull requests, you'll see that there is a comment coming in from these bots. And if you ever wonder how these bots are being set up so that they could intelligently respond back to some of the issues within a workaround or even provide some feedback on a pull request, then this is the series for you. In this series, I'm going to walk you through how to create a GitHub bot that looks at any code that has been submitted as part of a pull request and looks at that code and provides some suggestion back as a comment within the GitHub pull request. Now, this video is very much for people who are interested in working with Golang and Gen AI. So I'm basically going to, the reason I chose Golang for this is because Go is a very modern language and it's very much in use. It has already been evolving over the last decade or so, because some of the biggest, most widely used systems like Kubernetes has been written in Go. And there is a lot of other benefits of it, right? If you're trying to scale currently and integrate with Kubernetes, Go is the go-to language, and it's also quite widely used, being for quite widely used for Gen AI. I use it in my work day to day, all the time, basically. And it's actually a fun language to use as well. It's very different, I'll say, from other languages, but it's very handy as well. The other thing I'll do is take you through AWS Bedrock. I'll give you an overview of it. So Bedrock is the Gen AI kind of platform within AWS, and they have got some good stuff running in there. In this video, initially we're just going to be looking at interacting with their foundational model, but in future videos I'm actually going to be also talking you through how to integrate with their knowledge base, their data sources, vector indexes or vector stores, creating an agent, putting guardrails on it, and a lot of other stuff, which probably wouldn't make sense much now if you're new to all this. But that's what I plan to do over this series that I'm doing with Gen AI and Go together. So this GitHub bot that's what I'm going to be focusing mainly this particular series on, is going to be written in Go. It's going to be a Go application, and I'm going to take you guys through right from the very beginning. So we're going to go installs and set up Go, and after that we're going to start writing code for it. And throughout this entire series, I'm going to take the time, stop, and show you how to debug within Go, how to interpret results from the debug console, and work with unknowns. Because on a real life, if you're aspiring to be a platform engineer, or if you're a junior platform engineer already, right, one of the key skills to learn is how to debug, how to troubleshoot, and how to work with a problem that hasn't been solved before, right? Which is quite common when you're working with like HTTP requests. So hopefully, which we will be doing quite a lot in this video series. So hopefully that will be quite useful and beneficial to a lot of people. So without any further delay, let's go ahead and actually start our first step in here, which is to go to the download page in Go. You can just Google Go or Golang, and that will bring you to that page. From there, just click the download, and once you're here, you've got this Linux tarball that you can download in here. So just go ahead. Well, I'm on Linux, but if you're on any other OS that are in here, then just choose the appropriate one. In my case, I actually need the ARM64 one, so I'll go ahead and download that. And once that's been downloaded, we can go ahead and actually install it. So for that, go ahead and click on this installation instructions in here. And if you already have Go, there's some tips on managing multiple Go installation, so you can follow that. But here I'm going to take you through as if this is going to be your first one, or you want to just keep one version of Go. So go ahead and copy this command and open up the terminal. So in the terminal, just copy the paste that. In my case, I actually need to change this to ARM. So I'm on an ARM chip, so that's why I've changed it. But if you're not on an ARM chip, you can just run this command. If you don't know which one you are running at, then don't worry, just run the command. If it fails, then you know you need to change it to ARM, basically. And you also may need to add the sudo, depending on how you set up your local instance. So it may take some time, but it should be installed. And we can just double check this by running Go version. So there you go. So it's installed and it says Linux ARM64. But I've already got it set up in my path. If you don't know what path is basically a way to sort of tell if you're on a Linux OS on how to recognize a particular binary or application throughout the entire system. So I really recommend go ahead and copy paste and run that basically. Or even better, just go into your profile if you don't want to be running it again and again basically. So as in, don't just copy paste this and run into a terminal, because that's just gonna make sure that Go is recognized within that particular terminal, right? Whereas you want it to be recognized across the system. So even if you open up 2-3 terminals and you want to interact with Go across all of them, you still want it to work. So that's why just follow the instruction in here, open up your profile, and just copy paste the export path command in there for Go. And then you are all set. So the next thing we're going to do now is we're going to go ahead and let's make a directory first where we're actually going to be writing our code. Let's call it GitHub bot. Then we're going to go into the directory and let's go ahead and actually initialize a Go module here. So to initialize it, you just need to do go bound init. Most of the time they are GitHub repos, and the pattern or convention is to follow something like this. So you do github.com and you then just do github-bot. Obviously you're not tied to this pattern, but if you follow this, it's probably better, just to stay with the rest of the world's convention or rest of the other people who are working with Go in open source. So now the module has been created and I'm going to go ahead and use VS Code. You don't have to use VS Code, but I would highly recommend because it's very good for Go. There's a built-in extension from Google, which is very helpful when working with Go. Right, so we've got our Go module in here that has been initialized, and before we actually start writing in Go, I'll just show you about the Go extension. So you just want to go in here and search for basically Go. And I already have got it installed, which is this from this Go team at Google. So this is the one you want to install. So just go ahead and install that if you're on VS Code. Now let's go ahead and create our first file in here. We're going to go ahead and say it's main.go. And in here, we're just going to do, so first thing we want to do is give it a package. So the package in here, I'm just going to call it main. So this is the main package, and this is going to be the main entry point for our code or this application, let's say, right? And in here, I'm also going to go and create a main function. So this main function is what that's going to be called when the application runs. And we're going to initially start off writing all our code in here, and well, in this particular Go file, and we're going to have a couple of functions. But I'll also show you how to refactor and kind of set up for a large code base in here. What are the principles to keep in mind as we go along? So just bear with me on that. So just to make sure that this is all working and the Go program is running, let's just go something very simple. We're just going to go and do format.println, and we're just going to pass in there hello world. Yeah, nothing ingenious here. So what this is doing, the format is basically a module within Go, and we're importing it, and it's got the statement println. So println basically just prints out a particular string onto the standard output, right? It just prints out strings to the standard output, and we are basically, once I run this, expectation is that I'm going to be saying hello world displayed in the terminal, right? So we're just going to go ahead and run it. And I'm also going to show how to set up a debugger or a launch.json file within VS Code for Golang. But that is coming very soon. But before that, let's just go and do go run dot. So this go run dot basically just looks for this main.go file, and it picks it up, and there's a main function, and it just literally what it's been told to do, prints out hello world. Simple as that. So now that we know the applications are working all well, let's go ahead and actually start doing some real thing. But before we do that, let's quickly set up a launch.json file for Go. This is going to be super useful, as this is what we're going to be using to basically debug this Go application code. So what you want to do is click on Go launch package. Once you click on the Go launch package, it's going to open this up, and you don't want to do folder name. Instead, what you really want to do is make it across the workspace folder, and then just do main.go. So your workspace folder being, in this case, this GitHub bot, yeah? And you just need to refer main.go file. Now, once this is set, just to close that on off, and now we're actually going to get rid of this, and let's actually write some real code related to the bot. So first thing we're going to do is http.handle func. So I'll get into that in a bit. Let me just write a few arguments or pass some arguments to it. I'm going to call it webhook, and we're going to be passing in a function here, and let's say it's called webhook handle func. Okay, right. So what's this HTTP handle func? So HTTP, first of all, is a module within Golang, and it's one of the most commonly used module within Go to interact with HTTP requests, right? So in this case, what I'm trying to do is that I'm trying to handle a request that's coming into an endpoint with the path /webhook basically. And then I'm passing in another function, which is supposed to be triggered when the request comes onto webhook. And HTTP package is the module within Go to allow you to handle this kind of stuff, right? To trigger something based on a request coming onto an endpoint. This is also the same module that we'll see later on in this series that will be used to, send GET requests, POST requests, and so on. We will also use this module to write and throw HTTP errors within Golang. So it's a very handy module to know, and learning how to work with it can be super useful. But yeah, so what's this now coming back to this handle func. The handle func basically is a function that looks for a match, right? So you pass in a pattern to it, as it says in here, which usually is a particular path. And to that path, you then pass in a kind of a handler. So handler, in this case, think of it like a mapping function, right? So every time something comes into this path webhook handle func is going to be triggered. So webhook handle func is going to be just another function, basically. And this function is basically going to be taking some parameters. So if you look at this, you can see that it needs a parameter, HTTP response writer, and star HTTP request, right? And so it can't be empty. We have to pass in these parameters. So let's go ahead and copy them. So, and we obviously, these are the types in Go, and we need to give it some. So writer is the name of the argument, and this is the type for that argument. And here we're just going to say request. And request is the name here, and this is the type. So this symbol in here, the asterisk, basically is referring to a pointer. And we're gonna come into working with that very shortly. But for now, what we are passing in here, or to work with any kind of Go function and pass in some parameters to it, this is how it works, you pass in the name of the argument followed by its type. And you can also have a return type, but for now we don't really want to worry about it too much. So now the webhook handle func is, so the reason we're doing that is because we are trying to set this application up to listen to requests coming in to this webhook endpoint. So what we're going to do is that we're going to configure in a GitHub repository a webhook, so that every time a pull request has been created, a request gets fired with a particular payload that contains information about that pull request, which we'll then capture and use that information to then pull out the actual code that was submitted as part of that pull request. And we want to automate that, right? Because we don't want to be polling GitHub for pull requests. We would rather get GitHub to tell us whenever there is a pull request being submitted. So that's the idea, and we are going to be writing and developing this webhook handle func very shortly. But before we do that, let's use another function from this HTTP module, which is called listen and serve. So what listen and serve does is that it basically takes in a address, or in our case particularly, it's going to be just a port, really, right? Because by default it's going to assume it's localhost, and it's fine for locally because we're going to be get this up and running locally. Then in a video further along in this series, I'm going to show you how to containerize it and run it in Kubernetes, and then actually do it all in the cloud, right? We're going to look at AWS EKS and how we run things there. But for now, it's just all local. And we're going to pass in nil in here. Right, so what's listen and serve, and what's the second argument? So the second argument in here is basically, typically, as it says here, it's nil, right? And the reason it's nil is because we're using a thing called default serve mux. Default serve mux is nothing but just a standard built-in interface within Go that just starts a server up. It basically starts a Go HTTP server up and listens at a particular address. So if you're running in the cloud, for example, you would actually probably want to add a real IP address, not just a port. But if you're running it locally, this should be fine. So go ahead and do that. And next thing you want to do for now, let's just do and add a standard output. We're going to say we're up and we're listening at port 8080. Let's just leave it at that for now. Our webhook handle func. Actually, let's go ahead and put that in here. Yeah. And then we're also going to do format print lane, let's say received webhook request. Cool. So now let's go and set up the actual webhook that I've been talking about. So to do that, we're going to go into the repository that I've already got, and I'm going to send a link to these repositories in the description of the video as well. So I've got GitHub PRBot. So this is going to be the test repository that I'm going to be using in order to actually trigger this pull request, right? I'm going to be submitting some demo code. We'll actually most likely go ahead and use some of this code that I'm writing here and send that across to the LLM for analysis and come back with further improvement suggestion. It'll be quite fun and interesting. Let's see what the feedback could be on the LLM, right? But anyways, this will be the bot, or this will be the test repo for that. So I have already got it pulled up, and I'm going to go to the settings. Oh, actually, before we do that, here is another important question, which is how do I actually expose this local address, right? Currently it's running locally, but how does GitHub know to reach this local address or local endpoint? The thing is, it doesn't. But we want to do it locally first before we do the cloud, because I think it's more simpler, and I want to explain these concepts in quite detail. So doing it locally definitely takes a lot of other extra overhead of knowledge away, right? So, but to do that, we need to use another tool, which is called Ngrok. So if you don't know Ngrok, just go ahead and Google Ngrok. So Ngrok is basically a very interesting tool. It's allowed to, one of its use case, which will be very appropriate for us, is to expose a local endpoint over a public IP address. And that makes it useful for testing and debugging situations like this, right? Now it's completely free. So all you want to do is go in here and basically just get started for free. If you already have an account, then that's great. You just log in there. In my case, I've already been set up. But what you want to do is, I'll actually show you, because there is a auth token involved and I don't really want to show my one. So this is how it works. You basically go to this download page and you want to do it for whatever you want, really, right? Like this is Windows obviously, but if you go to Linux, Mac OS, whatever your operating system is, just copy this command, run it, and that will install it for you. I've had this issue with the command in the past that I've had to actually manually copy paste and do it, right? So you may have, depending on how your operating system is set up, you may have some issues. So just bear in mind, if something is going wrong, just individually copy paste them and run it, and it will work. So then once you've done this, you need to go in and set up, just basically make an account within Ngrok. Once you've created an account, then you'll basically need to come to this setup and installation page. And once you click on the once basically you follow through, there's going to be a step where you will see the token with this command. So you just need to copy it from the setup and installation page and run it. And after that, you're basically going to be running the last command, which is what's going to allow you to expose the port. But see this thing over here about ephemeral domain and static domain. So ephemeral domain basically means that if you run it now, it's going to create you a domain. But if you like shut the terminal off, then that domain is going to be deleted forever. So you're not going to get that address back again. So if you go and use that address to set up your webhook in GitHub, if you're following this along, then that's not really going to work for you. So what you really want to do is static domain, and you want to copy this from here. It will, again, both of them are free, and this is just going to create a static domain for you. So you just want to go ahead and basically copy this and run, so that you got, so if you just go ahead, probably best to open up another terminal, because you just want to leave it running when you're working with this application. But make sure to change this to port 8080, or if you want to leave it at 80, then just make sure you come back to your code in here in GitHub, in VS Code, and change this to 80 as well. Yeah. But yeah, I use port 8080 pretty much for most of our application that I work for my personal projects. Right, so if I go back now and go ahead and run this, it's basically going to be starting this up. So it's all good. Then what you want to do is come down in here and copy it. It will take you to a page if you do click on it by mistake, but don't worry about that. Just come into GitHub now. So basically, if you have cloned this repository into your personal repository, you can go in and add webhook. So this is under settings on the repository, and then you want to go and do add webhook, and in there you just want to paste the address you just copied from Ngrok's from the terminal, and make sure to add in the webhook, right? Because otherwise the request is actually not going to be forwarded to what we have done in here, because we have set webhook in there. So now go back in here. We want to do application JSON because we want to get the data in JSON. It's just much easier to work with and parse and map to. And you definitely want to do, let me select individual events in here, and then you want to do pull request, and you want to do add webhook. Just make sure it's active. Now that it's up, let's go ahead to our pull request page and let's go ahead and actually create a new pull request. So I'm actually going to go to this repository. You'll get 502 bad gateway, but that's because your application is currently not up and running. We haven't run it yet. And actually, let's go ahead and run it because it doesn't really hurt. So we're going to go and click on this. So if you have followed my instruction and set up this launch.json file in here, which shows up under .vs code, then once you go to this, click on this icon, it should take you this launch package. And you can just click on the play button in here, and that will basically start up your Go server. And once it's up and running, you'll see this. This means that it's running and it's listening to a request now. So we'll go ahead and actually submit a pull request. So I've already got the PR bot repository. I'm just going to open that up in VS Code as well. Excuse me. And I'm going to readme.md file, and I'm just going to basically push that up. So if I go and do say git checkout -b, let's say give it a name, PR trigger test, and now let's say yep, that's all good. Let's do that because I did add a main.go file in the past, but I thought I'd delete it and do it all from scratch. Let's just do test PR, and let's just go ahead and do a push. Oops, yep, I need to do that. Run it. So now that this branch is up, PR trigger test, we're just going to go and submit a pull request for that. And we should see that there's a request, or we should see that the code is basically going to go and stop in this breakpoint in here. So let's say received webhook request, yeah. So let's go ahead, create a new pull request. And let's choose PR trigger test. And let's create it. Click it on there. Now if we come back to our code, you see, there you go. The request has come through from GitHub through to Ngrok. Now if you go and look at your Ngrok terminal, you'll see that there is a 200 OK here, right? Because the application is up and running and the request is flowing in fine. So now what we're going to do from here is we're going to kind of inspect what's in this request, right? And I'm going to show you how to kind of figure out what is the important information of data you need from the request body, right? And how can you design different types or data structure within Go to work with it. So the first thing to do now is let's go ahead and hit the stop button in here. And what we're going to do now is let's read what's coming in. So we know that we've got a request coming in here, and we know that the request has got a body. So let's get, actually we don't need it. Let's get rid of one of the statements. And here we're now going to do, let's say body, comma, error. I'll go into what they are in a sec. Let's do io.readAll, and we're going to pass in request.body, right? So what's going on in here? So first of all, io is a module within Golang, and this basically allows you to read. It opens a data stream up, and you can read the data from it, and the data is basically then read in the form of a byte array, right? So if you look at the outputs in here, you can see that it returns This particular method here returns a byte array and an error. And that's why I've got two different output variables in here. So we're literally just reading everything from the request body as a byte array. And the reason they are getting highlighted in VS Code is because they are not used. So Go does not allow you to run a program if you're not using these variables, right? It's going to run into an error. So if I do, for example, go run.now, see, it's a declare and not use, declare not use. So you're not going to be able to run it. That's just how Go has been designed. So you basically want to make sure that these variables are being used. So the first thing we're going to do is do if error doesn't equal to nil. We're just going to go, I didn't really actually speak about the nil term. So nil is a special keyword in Golang, and what it does is that it basically just represents a zero identifier for a particular variable, right? Whatever the variable may be. And here it's basically saying if there is no error, then it's all good. But otherwise, we are going to throw in a HTTP error in here. So HTTP error is basically allows it makes sense to throw a HTTP error here because we're dealing with HTTP requests, right? So so in this case, our error really is that we fail to read the request body, yeah. And let's also, so this HTTP error takes in 3 arguments. So the first one is the writer, and second is the actual error message, and the third is the code associated. So in our case, we want to throw it as a HTTP bad request, really, which is like status bad request. And the writer, we already have it based on the arguments required for this handle func, right? And now we also want to do a return. So if there's an error in reading the request body, then we don't want to go any further because that's the most important thing here. And as we have opened up a read stream in here, we're actually going to also do a differ. So let's do differ request dot body, and we do close. So what does this differ keyword do here? So differ is an interesting keyword within Golang. What it does is that it delays the execution of a particular command or instruction until the enter function has finished, right? So let's say I've got 20 other lines underneath, right? All those lines would run, and then the function would exit, and right before exiting it, it's going to call the request.body close command. And this is very handy to do if you're working with like reading from event streams within Go, or like from the channels within Go, or any sort of data stream. Like in this case, we are opening up. You just want to write a differ. After you have opened it up, done the error handling for it, you just want to basically do a differ on closing that. The reason you want to explicitly close that so that there is no like performance issues or memory leak. It's a best practice. So that's what the differ do. It just delays the execution of a particular instruction until the function is about to exit. So we are then also going to be looking at dealing with body. So what is this body, right? So let's go ahead and for now, let's just do format.println. It doesn't really mean anything, but we're just going to do that. We're going to put body in there just so that Go is happy. And I'm going to show you what this body is actually. So let's go ahead and run our program. And we're going to go and let's say, actually, let me stop that. So let me also, we're going to make this more automated soon. I just want to show you how things look from scratch. So close it. For now, I'm going to go back and I'm going to run my package. Now that it's up, I'm going to basically go back and reopen the same one so that the request comes through. And I did not really hit a debug point. So let me just go back and actually do the same thing again. Sorry about that. Well, this will still trigger it, but what you'll see, I guess this should be fine too. What you'll see that it comes through, and we step over it. Now, what is the body? So body is basically, as expected, an array of bytes, which doesn't really mean anything to us, but it does have meaning. Since we said application JSON when we set up our webhook, we know that it's a JSON encoded data that's coming in here. If you look at the string, you'll see that there's more information on it. Now, you can see like it says 24622 more, which isn't really useful when you're trying to work with this data structure and extract out only the useful bits of information that you need. And even if you do something like convert this whole thing to string, right? So let's say I do something like body string equal to string body, right? Even that doesn't really mean much. So if I do body string, as in what I mean by that is that you're not really going to see all of the body string printed out on the standard output either, because there's so many. So I'll just quickly show you that to you as well. Also, if you're wondering about this colon equal to syntax, what this is doing here is that normally if you want to set up a variable in Go, you do something like var test equals to string body, right? That's what you do. It's red because I'm not using it anywhere else yet. But a shortcut for this, it would also be just adding a colon in front of it, right? That would do it. But you can only use this particular way of declaring and initializing a variable within a function. This is not going to work like outside a function in here. So that's the problem. But inside the function, you can just keep on doing that. That's not a problem. So now I'm going to show you what this body actually is, right? So to do that, let's go ahead and hit a breakpoint. So the breakpoint is going to be in, let's say, here. And we're going to go back to the browser and let's go and reopen the pull request. Once it comes through, I haven't actually run my program, so that would help. So let's go ahead and get the, right, of course. So Go, as we've seen earlier, isn't really gonna let me run without actually doing something with the body. So let's do format println body. And I'm going to now run the program. Now I'm going to go back in here and let's do a close pull request. That should still trigger the webhook. Now we can see that this has got a body, so let's go up, or let's step over it. So now if you look at body, it's just a array of byte basically, which isn't really that useful to us. However, you can see that it's in JSON format, so that's because it's JSON encoded data, because in the webhook we chose it as application JSON. Now here you can see that it's 24622 more. Now that's not really useful to us when you're trying to look through what actually exists in the request body, and then trying to create this, trying to extract only the meaningful parameters. It helps to sort of search through all the keys that are available in that request body. So in order to do that, what you probably ought to do is do something like string and then pass the body in it, and that would just do something like this, right? But if I just come out of it, I'll actually do, now let's do body string, and you then just do string body, and you do format dot print lane, and you just pass in the body string there. Now that should print out the whole thing in here, right? You wouldn't see that 21,038 anymore, so you'd have a clear picture, which we can then copy paste and just paste on the IDE and then search across it to get all of our parameters and look at them more easily. Also, a quick note on this, if you're wondering what this colon equal to sign is, that's just a way to basically initialize and declare a variable within Golang. This you can do only within a function, right? You can't do, like, you can't copy this and do it over here. That's going to be a problem, because here you'd want to do something like this, var, and you wouldn't, in that case you wouldn't be able to use the colon. So this is a way to declare initialize a variable within Golang outside a function. This also works in here, right? Obviously I've already got a variable like that, but this would also work here if I didn't have this. But inside a function, it's usually a pattern or a practice to just use the colon and equal to symbol to declare and initialize a variable. Right, so let's go and run this again. And I'm going to go back to my pull request in here once the application is up. And then I'm going to reopen it. And I'll see that now I can see that I've got all of it, right? Because it's printing it all out. And I could just copy it all basically and paste it somewhere here for now, right? Just click on show more and we can just search and query across it. Just do a Control F. So we need some of the interesting things in here, right? First of all, we want to log this action. But before I do that, let's talk about type a bit, right? So type in Golang is very widely used. And what is type? So type is very similar to, if you're coming from an object-oriented programming background, like from Python or JavaScript, right? Java as well. Anyway, it doesn't matter. If you're coming from any object-oriented programming language, it will look similar to that, but it's not, right? You can't really inherit types, whereas in object-oriented programming, you can create a class, inherit from it. You can extend it either, but you can use type to compose things, right? That's what's really used for interface and composition within Golang. And type is a very, it also is very interesting way to kind of, it allows you to map directly from JSON data into a Golang type, which we'll see in a bit basically. So let's go ahead and actually set up a type. The reason we need type is we want to have a structured kind of data store that has a standard set of information about a particular pull request every time the webhook sends a payload. So from the payload, as you can see, there are like 20,000 plus parameters. We don't really care about most of it. For our use case, we really just care about things like the pull request URL. We care about the pull request number, the title of the pull request, then let's say the repository, the commit for the pull request. And yeah, that's it for now. There will be more types, but let's go ahead and start with that, right? So the first thing we're going to need is actually, let's go and give it a name. So let's call it a GitHub PR payload. Yeah, and let's make it a, so the struct type actually is a struct, and we're going to call the first item in this type, or the first field in the type, an action, which is going to be a string, and then we're going to add some JSON mapping info in here. We're going to call it action. So what this will do, so we're going to use a method called JSON on Marshall, which I'll go into a bit more depth very soon. But essentially what we want to do is kind of map any JSON keys automatically to these fields that we're defining here, and that's why this is important. So then I don't need to actually explicitly say that pull out the value for the key action and then store it into this action field within the Go type, right? Go will automatically do it. It's smart enough. It's designed to be smart enough that when we call the JSON on Marshall method on a payload that has the action key, it's going to automatically pull that data and map it into this Go type. So avoids a lot of boilerplate code basically. And then we're also going to need to store information about the pull request. So let's call it pull request. We're going to call it string. And if we go up in here, we see that there is a key called pull request. So we're just going to go in and provide the JSON mapping for it. Well, actually, that's not a string, which is my bad. It's actually a map of its own. And we don't need all that information either. So we're going to create a type of its own, actually. And we're going to call this pull request too. But in here, we're going to say pull request. And make sure that you put quotes around them. Otherwise, you'll run into errors. Now, before we go any further, let's create a type for pull request itself, right? So in this case, I just put one of the primitive types in Go, which is string, but pull request is not a type within Go. I have to create it. And the reason I'm creating this is so that I only handpick a certain parameters from the pull request. So, for example, if I look at the pull request, we really are interested in URL we may not need, but let's keep it for now. So I'll take the URL, and then what else have I got here? Let's have a look through. ID, don't really want. HTML, probably not that important. Diff, no issue. We probably want the title. Yeah, let's take the title. Probably want the number as well, peer number, because peer number is used to actually. So if you look at the pull request URL in here, you see 7. So that basically means it's the peer number. So we'll need this to actually go back and fetch the files that have been submitted as part of this PR. And then also then actually pull out the contents of that PR. We need the PR number. So we'll need to store that. And state, probably not, since we've got action, and there should be a property for the actual commit hash as well. Let's search for it. It's usually called SHA. Not the merge commit. Okay, not SHA. Actually, let's do head. Yeah, there you go. So we got the head. And inside head, we should have the property for the commit. Yep, there you go. So we need to extract this SHA property as well. And we just want to get the repository full name too. So the repository full name is also going to be useful for constructing the URL later on. So it's useful to have. So Power Platform Engineer / GitHub peer-bot, which essentially is for us to dynamically generate these strings and replace them, right? Which we'll need later on. So, right, with all this in mind, let's go back to our type and create it. Yeah. So we're in pull request, so we know that there is a URL which is of string. We're going to do JSON and put it as a string in here. Then we got number, which is an int. We've seen that as well. Just do JSON number was the key. Then we need to get the title. We saw that was a string. Oops, title is a string, and it was JSON title. And then we have got head, which we just saw, but head was a map, so we're going to need another type for it. And let's call it head. Cool. Right, let's go and create a type for head now. So type head, which is going to be a struct, and inside the struct we've seen that it's called just SHA, so it's just called SHA, just of type string, and it is mapped to the property SHA. Okay, so now you don't have to do it like this, right? You could like literally just do, instead of doing it like this, you could just do this as well if you wanted to, so then you don't have to create it. But I mean, during my work and professional experience, I've always done it in a more broken down manner, like how I've done in here, because it's more easier to follow, easier to maintain and read through really. So it helps with readability, especially when you're coming back to the code base after a month, right? So that's why it's good idea to keep it separate still. Then we also need the repository full name, but that was a map, I believe. Let me just double check. Repository, what was it looking like? So repository is here and it's a map. Okay, and inside the map I've got full name. That's what I wanted. So I'll go back here. Let's go, and so I need repository. I'm gonna put it as repository in here. I know that it's called repository. Now repository again, another type, so let's go and define that too, even though it's just one, because it will help with readability. And we know that this is called, let's name it full name. It's a string, we know that it's going to be JSON and it's going to be full name. Yep, cool. So that's repository, all done. So now we got a type called GitHub peer payload that has a composition based on these other smaller Go types. Right, so now actually let's go and use this in our code in here. What we're going to do is first declare a var, and we actually don't need this anymore. So let's go. The body actually doesn't need to be a string. I just made it into a string so I can just actually read through it. And this is actually a useful skill to know so that you can debug. Because most of the time in real life, if you're working in platform engineering, you're dealing with some HTTP requests, right? You're going to want a way to decipher it, especially if you haven't worked with it before. And this is a good way to kind of look through what the request body contains and then set up your code further based on that information. Right, so now let's go and declare a thing called, let's call it payload, and we're going to call it GitHub peer payload, right? So this is the type that we've just done. Yeah. And this payload again is because I'm not using it anywhere, but we will very shortly. So now we're going to go and do if earn doesn't equal to json.onMarshall, and let's pass in the request body in here, and we're also going to pass in the pointer to this payload variable, right? So what's JSON on Marshall? Let's talk about it a bit. It's very useful and very handy. So what JSON on Marshall is, so it's expecting, as you can see here, an array of byte, which is usually JSON encoded data, and then it's expecting a target essentially, and the target usually is a pointer. Now, what's a pointer in Golang? So pointer basically is an actual reference to this payload in here. This GitHub peer payload, and this is basically the target where the JSON data, based on the definition of the type in here, right? This JSON keys, any matching fields with these matching keys are going to be automatically parsed and populated within this payload variable in here, right? And payload is nothing but these fields within the Go type. So action is going to have the value of action, pull request is going to have all the map for pull request based on the fields that we have defined here. And that's what the onMarshall does, right? You have to pass in a pointer, because if you go into the onMarshall's documentation, it says if it's nil or if you do not pass in a pointer, you're going to run into an error. The reason it does it is because it needs a target basically to write something into. If you don't pass a pointer, normally, like in this case, you have to pass a pointer because that's what the method's expecting. But normally, if you don't pass in a pointer within Golang, it's just going to pass in a copy of the variable, right? So let's say I've got body in here, and if I pass body into something, it's instead of its pointer, it's going to take the actual content of it. Now in this particular scenario, we haven't got really a variable, we just declared it. We haven't really got any initialization for it. So we are just storing all that data from the request body in here. And we're then just going to do some error handling. So we're just going to do equal to, let's say, nil again. So if it's not nil, and this is still probably still a HTTP error, so we're just going to go ahead and throw writer, let's say something like fail to parse JSON encoded data, and we're going to still use the bad request, right? And now you may be wondering, why is this if statement is a bit different than this, right? They're not the same. So the reason, like, we could certainly do something like this. Yeah, where we do error, right? We could do something like this. Ignore that. That was my mistake. I got confused a bit. But essentially, I could handle it just like this as well. But what I was doing is just another way of kind of wrapping this whole thing through, because this just makes it a bit more, it just wraps it around and it just makes it much more easier to read through. In this case, because JSON.unMarshal body and payload, I don't really expect anything as an output of it besides error, right? So what I'm saying here is that if I'm getting error as output of this, then I'm just storing that into this error variable, like the content of the error, and then I can check that if it's nil or not. And if it's not nil, then I'm actually throwing an HTTP error. So that's what it's doing. And it's just a more neater way of writing that, basically. Now, this is not going to work in cases where you're actually expecting an output. So here, for example, it's not just error that I'm getting as an output. I'm also getting body as an output. So I can't do that like this in here. In those cases, it's best to just try to handle the error separately. But yeah, now if I actually show you what this is looking like payload is going to be populated with some data. So let's go ahead and actually do let's just do a return here for now. And we're going to go ahead and stop this program and then run it. And we're going to put a breakpoint, let's say, in the return. Yep. And now if I go to here, and let's say I want to close the pull request, and I come back down, and if I look at the payload, you'll now see that the payload is actually populated. So the action field is getting the data from the action JSON field. Pull request is populated with all this information. Head is its own struct. It's got the data for SHA. Repository has got the data for the full name. So all this is happening without me having to write any line of code to actually say map this to that, map action to action, pull request maps to the pull request struct, and all that type of boilerplate code just disappears. Just all because of tagging it like this, right? So there's still some mapping to do, but it's pretty much, it's just a bit more neater, essentially. But anyways, so what we don't want to do is actually go forward with this application if the pull request is getting closed. We really just care about if it's open or reopened. So what we're going to do is let's stop this application and let's go ahead and do something like if payload.action is equal to oops, say opened, or let's also do reopened, because it is possible that, well, since we're testing specially, that I'm going to be reopening this MR. So what we're saying now is that this is where a bulk of our code is going to be happening, right? Where we're going to be going and fetching all the files that are associated with the PR, and then actually getting the contents of the PR and checking if it's actually a code related file or not. Right? We don't really want to be taking the contents of README file, for example, and sending it off to the large language model for improvement, because that doesn't really make much sense for our purposes. So yeah, so let's just go and do something like a printf. So just format the printf, just formats the string, basically very similar to their counterparts in other languages like Python. So here we're just going to do %s, just formats a string variable, and we're just going to say it's ready for review, and we're just going to use the title property from the payload. So yeah, so let's go ahead and actually run this now. We actually don't need this search bar anymore. So yeah, so let's go ahead and run it. So now we should only get this printed to our standard output if the MR is either reopened or open. So in our case, luckily we can just get to reopen it straight away. So let's reopen it. And if we come back down here, we'll see that PR trigger test is ready for review. So PR trigger test is the actual name of the PR, basically. So that's why it's showing up. So PR trigger test. So yeah, so just to recap, in this video we basically looked at how to go and get started with Golang, and then how to set up the debugger for it. Oh, actually, one thing I missed out before I finish, I just remembered, is that to debug in Go you're going to need a thing called delve, and I probably should have walked through it much earlier. So if you've come to this much further in the video and don't know how to do delve or haven't got this set up, I am going to send a link to it in my video's description, and here's going to be a installation section for it. So you basically just need to go and copy the command for it, basically, depending on your OS again. So just get the latest release, just copy this command and run this basically in your terminal, and then you'll be good to go. So anywhere in your terminal, basically, and that will ensure that the debugger for Go is installed for you, and you can actually use it in VS Code. I'm actually, during my edit of the video, I'll mention that this is actually by mistake, unfortunately, mentioned near the end of the video, so that people don't get lost. But yeah, going back to this, just to recap, so in this video we looked at how to set up Go, how to set it up for debugging, and how did you actually set up Ngrok to kind of expose a local endpoint to over a public endpoint, so that GitHub API or GitHub Webhook can actually send a request or forward a request to it. Then we looked at some of the internals of Go in terms of how to work with the HTTP module, how to read data from it to get the byte slice JSON encoded data, and then convert that into a particular Go type, which we created and walked through, and how we can automatically map from JSON keys to Go fields without doing much work. So there's quite a lot of different things going on in here, especially if you're quite new to all this with Golang. So just bear with me. In the next video, we're gonna focus purely on Golang, really, and we're gonna just go more forward on how do we actually fetch the contents or the files associated with the PR, and then actually get the source code that are in these files, and then send it across to a large language model in AWS Bedrock. And I'll also give you a overview of AWS Bedrock in the next